And we're back for more. I just made 11.1. We'll also do 11.2. This should be pretty fast, so 11.2 is summations. Here we go. Go ahead and copy this down. Summation is just a way of adding terms using a formula. So you're going to see summations that look like this, and it probably looks weird at first, but you're going to see that it's really not that bad. So you have this E looking thing, but it's not the letter E. It's the capital sigma from the Greek alphabet. So don't call it E, call it sigma. Actually, most of the time we're going to say sum. In fact, let's go ahead and make a note of that. We're going to be calling this a sum most of the time. And you probably saw on my board at some point, someone wrote Cynthia Sanchez, right? Ooh, I just shouted out name there. You probably saw this written on the board at some point. I ate some pie, because we call those sums. Alright. I'm being silly today, I'm sorry. So, let's talk about what this is. K equals 1. What that means is you're going to be plugging in K equals 1 into this explicit formula. You're going to keep plugging in K values from with whole numbers, starting with 1 and ending at 5. So you're going to be, and you're going to be adding all those up. So you're going to be plugging in K equals 1, K equals 2, K equals 3, K equals 4, K equals 5, and then you're going to add up all those numbers. So I'm going to show you just how that's done. I think by now something this is going to be pretty easy for you guys. So here it says expand these series and evaluate, but that just means do what I just said. So we have the sum, the way you say it is the sum of 1 over 2 to the power of k from 1 to 4. Okay, the sum of 1 over 2 to the power of k from 1 to 4. And it's easy. You plug it. You start with plugging in k equals 1. So that's 1 over 2 to the power of 1. You throw a plus sign in there. So now you can do k equals 2. So you do 1 over 2 to the power of 2. Plus, we want to now plug in k equals 3. That's easy. 1 over 2 to the power of 3. And then, where do you know when to stop? Look at this number. So we're going to stop at k equals 4. Okay, so we know how to do powers. 2 to the power of 1 is 2. So this becomes 1/2. 1 over 2 squared is 1 over 4, because 2 squared is 4. This becomes 1 over 8. And this becomes 1 over 16, because 2 to the power of 4 is 2 times 2 times 2 times 2. Okay, depending on how how I want it, or how the EOC wants your answer, I mean, you could probably plug this into your calculator and get a decimal. But how do you do that as a fraction? Like, how do you get this into a simplified fraction form? Imagine you're on the EOC and you don't have that nice fancy calculator that can convert from decimal to fraction. What do? Well, if you're adding fractions, you need to get a common denominator. All right, so let's make a note of that real quick. Denominator. All right. Luckily, a problem like this, all of the first three denominators go into 16. So it looks like our common denominator here is going to be 16. So I don't need to change this fraction because it's already a denominator 16, but I need to change all these other ones. Now, to change 2 into 16, I'm going to have to multiply the top and bottom here by 8. To get 4 to become 16, I'm going to have to multiply the top and bottom by 4. And then by 2 here, because 2 times 8 is 16. Let's see what happens. 8 times 1 is 8. And all our denominators are going to become 16, so I don't need to talk about that. Bring down the plus sign. 4 times 1 is 4 over 16. Bring down the plus sign. 2 times 1 is 2 over 16. Bring down that plus sign. And then we have the 1 over 16. All right, now that you have your common denominators, don't add the denominators. Remember, your final answer will still be over 16. You don't add 16s up. But you do add the numerators, add or subtract depending on the problem. In this case, we're just adding all these numbers up. 8 plus 4 is 12, plus 2 is 14, plus 1 is 15. So this is your answer as a reduced fraction, not as a decimal. You got to be able to do that. Let's go ahead and do this one. Now this one, we're starting at k equals 2. That's fine. And we're ending at 6. So we're going to plug in 3k. So we're going to plug in k equals 2. So we have 3 times 2 plus 3 times 3. And I'm going to keep doing this process all the way up until I get to 6. So 3 times 4, 3 times 5, and 3 times 6. Okay. Just remember order of operations as well. Don't forget that. Remember, you got to do 3 times 2 is 6. Bring down that plus sign. 3 times 3 is 9. Bring down this plus sign. This is going to be 12. This is 15. You know, just bring down the plus signs, doing my multiplications. And now I just add these up. Well, I know that 12 plus 18 is 30. This is 15, so it's 45. So this should equal 60. Right? Let me just double check that I didn't mess up on camera. It'd be stupid. 15, 30, 60. Yeah. So that's your sum. And that's it. That's all there really is to summations. Why don't you try these out? Well, I'm not really suggesting that. You need to. Go ahead and write these down, and I'll have the solutions in the description so that you can check your answer. Okay? If you get these wrong, at some point in class when there's free time, you should probably ask me how to do this. All right, you ready for a math pun? I love this pun. This is from the last section, 11.1. We learned about sine graphs. So math puns are the first sign of madness. Ha 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 ha.